Okay. So, good morning, everyone. Uh, so, so this is what we have seen. Hmm. So, these are the things what we discuss. And whenever you do some arithmetic, so it will try to do broadcasting. I said, what is the meaning of broadcasting here? Okay. So, I said broadcasting is a process of converting of one shape to another shape, right? So, but whenever you do the broadcasting, so what will happen is NumPy compares the array shapes element wise from right to left. If the dimensions are the same, they are compatible. If one dimension is 1, it is stretched to match the size of the other dimension. If dimension is 1, it is stretched to match the size of the other dimension. If neither dimension is 1 and they don't match, what will happen here? Value error is raised. Okay. So this is the rules. So these are called rules here. So when it is doing a broadcasting, so these are the rules for broadcasting here. See here, let me tell you examples on this, some more examples. So for example, yeah, already I said about this, but here assume that you have assume that, so I'm writing import, so NumPy as NP. I create an array. Now this is nothing but single dimensional array, one dimensional array, say here one dimensional array. And then what I'm doing is I'm trying to say b equal to a plus, b equal to a plus. I'm trying to use which one? Scalar. I'm using which one? Scalar here. So what will happen? It will try to add each value to each element of which one? Array. And after adding it, what is the array? It is written 1D array. It is written which array here? 1D array. So with 15, 25, 35, 45 and what? 55. In the same way, I'm taking one more array. So np dot array. I'm creating an array of 2D array. So here, this is 2D array. And I'm writing d equal to c plus 5. Now this is also which array? 2D array. And when you print this, now you can see this value is added to each element of which one? Array. So that is nothing but 5 plus 1 is a 6 and 5 plus 2 is a 7 and 5 plus 3 is a 8 and 5 plus 4 is what here? 9. So the value is added to each element of what? Array. So that is 5 plus 1 is a 6 and 5 plus 2 is a 7 and 5 plus 3 is a 8 and 5 plus 4 is what here? 9. Okay. So these rules you have to find out. So these are the rules you have to find out. So see here, broadcasting in NumPy is a mechanism that allows arithmetic operations to be performed on arrays of different shapes. So virtually expanding the smaller arrays dimensions to what? Larger one. Okay, suppose you have a two arrays, np np dot array 1 2 3 4. So 1 2 3 4, and there is a y. np dot array, I am creating an array of 2D. Now 10 20 and 30 40. So total how many number of elements are there in both array? 4 elements. The number of elements are what here? Same. The number of elements are the same. I'm saying x plus y, and you are trying to print x comma y comma z. X comma y comma z. Now if you run this, now it is given what here? Error. So what is the error is? Operands could not be broadcasted together with what? Shapes. Now what is the shape of this array is? 4. What is the shape of this array is? 2 by 2. Now see the rule here. So if the dimensions are the same, they are what here? Compatible. If one dimension is 1, it is stretched to the match the size of the other dimension. If one dimension is what here? 1. One dimension is 1. So either one dimension is 1 means, for example, suppose this array is 1D array, but what is that? This dimension is 2D dimension, but in this, what is the shape of this is 2 by 2. But one dimension should be what here? 1. One dimension should be what here? 1. Suppose if I am writing like this, okay, if I am writing like this, okay, 10, and then I am writing which one? 30. So this is nothing but 2 rows and how many columns? 1 column. This is 2 rows and how many columns here? 1 column. You can see 11, 12, 13, 14, 31, 32, 33, and what? 34. So what is the rule is here? If one dimension is 1, it is stretched to match the size of the other dimension. It is stretched to the match to the other dimension. What is the another dimension is here? 2. What is another dimension here? 2. See here. This is 1 and this is 2D. But in this one dimension is what here? 1. Means how many rows are there? 2 rows and 1 column. Suppose assume that I'm taking P equal to NP dot array. I'm creating an array. See here. I'm creating an array with, so I'm writing 10 comma 20. So 10 comma 20. Now this is which array? Yeah, this is which array? 2D array with how many rows? 1 row and 2 columns. If I'm writing Q equal to P plus X. So P plus X means now this is 1 row and how many columns? 2 columns. And X is which array? 1D array. P is which array? 2D array. Okay. Now here I'm trying to say print. So P comma X comma X comma P comma Q. X comma P comma Q. And if I run this code, now here again it is given what? Error. Operand could not be broadcasted together with the shapes 1 comma 2 comma what is that? 4. Because what is the size of this is? How many elements are there in this array? How many elements are there in X array? 4 elements. How many elements are there in P? 1. How many elements are there? 2 elements. Now you can see this is. So if one dimension is 1, it is stretched. But stretched to match the size of which one? Other dimension. So one dimension is 1, but the size is same or different? Different. So if neither dimension is 1 and they don't match it, then it will rise which error? Value error. So here it is given which error? Value error. Operands could not be broadcasted together with shapes 1 comma 2 comma what is that? 4. Ring honor. So this is possible or not possible? Not possible. So these are the rules which has to be followed when you are working with which one? Broadcasting. But when this broadcasting is done, whenever you perform arithmetic operations, whenever you perform arithmetic operations on two different types of arrays with two different arrays with different shapes, two different arrays with what? Different shapes. So this broadcasting will be happen, right? So I think you understood this rule. If it is the same, if the dimensions are the same, they are compatible. If one dimension is 1, it is stretched to match the size of the other dimension. If neither dimensions is 1 and they don't match it, then it rises which error? Value error. So broadcasting only works if they are compatible. If the arrays are compatible, meaning their shapes match in all dimensions, or one of the dimension is what here? Equal. Meaning their shapes match all the dimensions, or one of the dimension is what here? Equal. One of the dimension is equal. One of the dimension is equal. So here in the last example, it is given error, right? See here, last one, it is given error. Why it is given error? Because is it match any dimension here? No, this doesn't match the dimension, right? So immediately it is rise which error? Value error. Getting on it. So for example, if I take, 10 comma 20 comma 30 comma 40. Okay, 10 comma 20 comma 30 comma 40. So how many values I've taken here? How many values I've taken here? 4 values. Now if I run this, but is it given any error? No, because what is the shape of this x is? What is the shape of x is? 4. What is the shape of x is? 4, right? So one dimension, but how many values are there? 4 values. This is which dimension? 2 dimension. With how many rows? 1 row. With how many values? 4 values. Each dimension is having 4 values. So one dimension is matches or not? Yes. Then is it broadcasting is allowed or not allowed? Allowed. Broadcasting is what? Allowed, right? So it is stretched to the dimension of which array? Another array. So another array, which one is second? The second point is this one. If one array has a fewer dimension, it is padded with ones on its left side to match the number of dimensions of which one? Other array. Okay, padding is nothing but it will add what? Suppose this is you learn when you work with the strings. Getting on her. So one string is having the width of 4. Okay, but you are displaying with the width of what? 6. Then remaining will take what? Spaces. Yes or no? So here also, actually your operand 1 means P is there and X is there. In this, P is which array? 2 dimension. X is which array? 1 dimension. Now it is automatically broadcast to which array? 2 dimension. That is what you mean by padding. Okay, right? Yes. Now this process, you call it as which one? Broadcasting. So whenever you do the broadcasting, one thing is it will compare the shape of both the arrays. And then next one is it will try to check is it one dimension is 1. It is stretched to the match of the size of the dimension here. Even this is also possible. Broadcasting only works if their arrays are compatible, meaning their shape match in all the dimensions of or one of the dimension is equal to, right, another array, right? Yes. So this you can call it as a broadcasting. But this broadcasting, as I know, it is done when you are working with the arithmetic operations. So let me tell you about mathematical operations so performed on arrays. So there are some mathematical functions which can be performed on which one? Arrays. So these operations you can call it as which operation? Vectorization. Vectorization. So it means you are performing this operations on each element of which one? Array. You are performing these operations on each element of the array. So NumPy allows to perform mathematical operations. So NumPy allows to perform mathematical operations on arrays. NumPy allows to perform mathematical operations on arrays. Just to compare the shapes. Okay, compare the shapes here. NumPy allows to perform mathematical operations on array. So these operations can be done using operators or using which one? Functions. So these operations can be done using operators. These operations can be done using operators or it can be done using functions. So two approaches are there. So you can use directly. Now it perform the operations on elements of the array. It performs operations on elements of which one? Array. It perform operations on elements of array.
କିଏ କରିବ? ହ୍ୟାଲୋ ହ୍ୟାଲୋ
NumPy allows to perform mathematical
ଆଜି ବା କାଲି
operations
କରିବ?
on array, and these operations can be done using operators or functions. It perform operations on elements of which one? Array.
ତାଙ୍କର ସଇଲା?
So you can use the operators here plus. Okay. So you can use a plus operator or you can use NumPy dot. You can also use a function called which one? Add. So there is an operator called minus, or you can use a function called NumPy dot subtract. So there is an operation called star. You can use NumPy dot multiply. So there is an operation called slash, or you can use NumPy dot. So NumPy dot float division. So there is a slash slash or NumPy dot floor division. So you can also use these functions percentage or NumPy dot percentage NumPy dot. What is this here? Mod. So next one is star star or NumPy dot. You can use what here? Exponent. So you can use the functions or you can also use what? Operators.
ଆଜି ସେ କଲେଜରେ ଡିପୋଜିଟ୍ କରିବେ
You
ଟି?
can use the functions or you can use the operators. So here anything you can use it. So NumPy dot. So what is the name of the function here? Add.
ଫୋନ୍ କର
So this is element wise. It is element wise. So element wise, which one? Addition of arrays. So you can also do this by using which one? Plus. You can also use what? Plus. Or you can use a plus operator, or you can use which function? Add function. Yes. So NumPy allows to perform mathematical operations on array, and these operations can be done using operators or functions. It performs operations on element wise, on elements of which one? Array. That is called as vectorization. So, but whenever you do these operations, it will do these operations by following which rules? Broadcasting rules. So again here broadcasting will come into the picture. Okay. Take an array. I take an array with the same dimension 1 comma 2. Okay, 1 comma 2 and 2 comma something. 3 comma what is that? 4. I can write C equal to A plus B. I can write D equal to numpy dot add A comma B. So these both are same. These both are same. So what it is doing? It is trying to add element of first array with element of what? Second array. So that is nothing but 1 plus 3 is a 4 and 2 plus 4 is what here? 6. Now I'm trying to say print A comma B comma C comma D. So these are different arrays here. So there are 4 arrays here, right? If you run this, now 1, 2, 3, 4, 1, 2, 3, 4 and 4, 6. But what happened? This is list, right? You have to convert this into numpy dot array. If it is a list, vectorization is allowed or not allowed? Not allowed. Okay. So if I use plus, it will do what? Addition, right? You can see 1, 2, 3, 4, 4, 6, and what is that? 4, 6. Because the dimensions of this both arrays are what? Same. Because the dimensions of this both arrays are what here? Same. Right? So I take one more array. Now there is an array called E. There is an array called E. E is an array. So NP dot array. NP dot array. I take a two-dimensional array by saying 1 comma, okay, 2 comma, see here, 1 comma, 2 comma, 3 comma, and one more is what? 4. See here, this is which array? This is 2D array with how many rows? How many rows? 4 rows. 4 rows or 1 row? 4 rows. With how many columns? 1 column. If you say E dot n dimension and E dot what is that? Shape. Now what is the shape of this array? 4 by 1. Means 4 rows and 1 column. 4 rows and 1 column. Right? Then there is a F. NP dot array. NP dot array. I created one more array with so 10 comma 20 comma 30 comma 40. This is what array? This is also which array? 2D array. 2D array, and here I am writing F dot shape.
ଖାଇଲୁ
So
କଣ?
this is having how many
କଣ
rows?
ଖାଇଛୁ?
One row with how many columns?
ଗଧ?
4
ଏଇଟା
columns
ଗଧ?
here.
ଶକ୍ତି ବାଚାଣ
This
ଘରକୁ ଗଲା ବା।
is 4 rows with 1 column, and this is 1 row with 4 columns. So is it a shape is the same or different? Different, right? But what will happen? The number of elements are same or different? Same. The size of this is what here? Same. What I am doing is G equal to F plus G equal to E plus what is that? F. So I can use plus. In the place of plus, you can also use which one? Add. Add also you can use it. And I'm trying to print. See here. So I've done with the different shapes here. You can see. Is it given any error? No, because why it is not given any error? Because one shape is equal to what? 1. Either 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 of these two arrays, one shape is what here? 1. 1, right? So if you run this code, You can see, 14, 24, 34, and what is that? 44. So this is, what is the name of this array? E. E is what? How many rows? 4 rows with 1 column. Now F is what? F is what? 1 row with the 4 columns. When you write here E plus F, 1 comma 4. See, first one is, this one you have to understand. If any one dimension is matched, 1 comma 4, so 1 comma 4 and 4 comma 1. So is it one dimension is match or not? Yes. Or two dimension matches here, right? So 1 comma 4 comma 4 comma 1. Any one dimension is equal to what? 1. Then is it broadcasting is done or not? Yes. But it is trying to stretch it to, see here. This is having, first array is having how many? 4 rows and 1 column. And second one is having what? 1 row and how many columns? 4 columns. 1 row and how many columns? 4 columns. Then what it is doing? It is stretching. Means it is broadcasting or not? Yes. It is broadcasting to 1 comma 4. You cannot convert this 1 comma 4 to 4 comma 1, right? You cannot convert this 1 comma 4 to 4 comma 1. You can see, what you can see here, some 14 and 24, 34 and one more is what? 44, right? But this is having different shapes. So that is E, F, and one more is what? G. You can just print this. Just use a separator. I printed 2 times here. Now when you run this code, you can see 14, 24, see here 14, 24, 34, and what is that? 44. But actually, so this is a first array, and this is what? Second array, and this is what here? Third array. See, what is the third array? I said E. What is the third array? See here. What is the third array? This is third array. What it is having? How many dimensions it is having? How many dimensions it is having? 4 dimensions with 4 rows and what? 4 columns. Now you can see this is 1 plus 10 is what here? Sorry. 1 plus 10 is what here? 11. And 1 plus 20 is what here? 21. And 2 plus 30 is what here? Sorry. 1 plus 30 is what here? 31. Right? And 1 plus 40 is what here? 41. So it is broadcasted to how many rows? 4 rows and 4 columns. 4 rows and 4 columns. That rule, a rule you have to follow here. Right? Yes. This is having how many rows? How many rows are there? 4 rows with 1 column, and this is having 1 row with how many columns? 4 columns. Now you are reading each time one element and you are adding it. You are reading each time one element and what? Adding it. See here. This is having only 1 row. This is 1 row. This is a first row and this is a first row. Will it, this element is added to, is it this value is added to each element of this row or not? Yes. So that is 1 plus 10 is becomes what? 11. And 1 plus 20 has become what? 21. 1 plus 30 has become what? 31. 1 plus 40 has become what? 41. Now take another row, 2, and it will add it or not? Yes. So that is 2 plus 10 becomes what? Yes. 2 plus 10 becomes 12. And 2 plus 20 becomes what? 22. So is it doing operation element wise or not? Yes. So that is, but when it is doing the operation, it is do what? Broadcasting. So it is converted this 4 into 1 and 1 into 4 into what here? 4 into 4. Because it has to be performed which operation? Arithmetic operation of each row is add with each element of each row or not? Yes. So here how many rows are there? How many rows are there? 4 rows. Here how many rows are there? 1 row. Then it will read each time 1 row or not? Yes. First row. And this is again taken what? First row. But number of rows matches or doesn't match? Doesn't match. Then what it will do it? Add. Add the dimensions or not? Yes. How many dimensions it is added? More 3 dimension. Now it has become what? 4 by 4. So that is broadcasting is done or not? Yes. So whenever it perform the operations on this different shapes. So what will happen? It will convert the shape of one array to another array. You can just see here E dot shape, F dot shape, G dot what is that shape? It's very simple. So there's no confusion here. 4 comma 1 and 1 comma 4 is converted to what? 4 comma 4. So it is add with 4 rows and 4 columns. 4 rows and what here? 4 columns. For example, if I'm doing it in reverse, right? Some x equal to f plus e. So f is which array now? Two-dimensional array with how many rows? One row. With how many columns? Four columns. And E is having how many rows? Four rows. With how many columns? One column. Now I'm trying to print. I'm trying to print what here? X. Now if you see X here, is it output is the same or different? Same. Because it is broadcasted to what? 4 by 4. But the rule you have to understand here. Broadcasting rule, what is a broadcasting rule? That rule you have to remember. So whenever it is doing the broadcasting, okay. So whenever it is doing the broadcasting, it follow these rules. Allows to arithmetic operations to be performed on different shapes, virtually expanding the smaller arrays dimensions to match which one? Larger one. Larger one. It enables element-wise operation between arrays without need to create what? Explicit copies of the data. You don't require to copy the data from similar shapes and it is automatically converted, right? So broadcasting only works if the arrays are compatible, meaning shapes match in all dimensions or one of the dimension is what here? Equal. One of the dimension is what here? Equal. One of the dimension is equal or not? Yes. So 4 is equal to what? 4. 1 is equal to what? 1. So one of the dimension is equal. Then it will perform which one? Broadcasting. If it is not equal, then will it perform broadcasting? No. See here, for broadcasting to work, NumPy compares the array shape element wise from right to left. Element wise from right to left. Broadcasting to work, NumPy compares the array shape element wise from right to left. So padding the dimensions, okay, compatibility it will check. Compatibility. For broadcasting to work, NumPy compares the array shapes element wise from right to what here? Left. Right to left. See here. So again I'm telling you np dot array np.array 1 2 3 b equal to np.array I'm saying 3 comma 4. Then tell me what is the shape of this array is 3. What is the shape of this array is 2. How many values are there in array A? 2 values. How many values are there in array B? Yeah, array is having 3 values and array B is having 2 values. So is it dimension is the same? Tell me, is it dimension is the same or different? Same. Both are what? 1D array. But shape is the same or different? Different. The shape is the same or different? Different shapes. Now what is the shape of this is? 3. What is the shape of this is? 2. Shape compatible or not compatible? Not compatible. Then immediately it is given which error? Value error. Is it match or doesn't match? Doesn't match. See, our operand could not broadcast together with what? Shapes 3 comma 2. Suppose if I'm trying to give, now in this, I'm giving how many elements? How many elements are there here? Array, how many elements are there here? One element is there, one element. But is it given error? No, because either array's dimension shape is equal to what? 1. Then will it perform broadcasting or not? Yes. Correct or not? Either array dimension is what here? 1. Then is it broadcasting is done or not? Yes. In 3 and 1, which one is bigger here? 3. So it is converted 1 into what? 3. It is converted 1 into what? 3. So very simple. The rule is very simple here. If array has a fewer dimension, it is padded with 1 on its left side to match the number of dimensions to what? Other array. See here. Number of dimensions of which one? Other array. Yes. Yes. The same thing. I don't want to repeat it again. Okay. But this rule compulsory you have to follow. Whenever it performs the arithmetic operation, it will perform the arithmetic operation by following which rule? Broadcasting rule. So here number of dimensions are added or not? Yes. So that is nothing but 4 comma 4. Yes. You can take 2D array or 3D array or ND array. Any array you take, but you have to follow that rules and regulations. So there is a plus. So there is a plus or numpy dot. Numpy dot, what is the function is? Add. So this function performs element-wise addition. This function performs element-wise which one? Addition. This function performs element-wise addition, it will do it, right? See, broad means always bigger. Broader means what? Bigger. Integer and float. If you do arithmetic on integer and float, it will convert into which type? Float type. If you do arithmetic on integer and complex, it will convert into which type? Complex type. Yes, because in integer and complex, which one is a broader type? Complex is a broader type. Bigger. Broader means what? Bigger. So 1 comma 2, 2 comma 1 will convert it into what? 2 comma 2. Correct or not? So because 1 comma 2, 2 comma 1, 1 row and 2 values and 2 rows and 1 value. So it will convert into what? 2 comma 2. Correct or not? So that is how broadcasting will be happened, right? Yes. Then there is see, all these are arithmetic. So rather than doing arithmetic on individual, yes. Now here I'm taking an array. So there is an array 2 by 2 matrix. So 10 comma 20 comma 30 comma 40. Now this is a 2D array. A dot n dimension comma A dot shape comma A. Now you can see what is the NP dot. So NP dot array. If you run this, you can see. So what is the dimension of this array? 2 dimension. How many rows and how many columns? 2 rows and 2 columns. And this is what? Now 10, 20 and 30, 40. If the array shape is the same, say a 2 comma 2. Here it is what? 2 comma 2. Then I'm saying it is a same. If it is the same, no broadcasting is done. If it is the same, broadcasting is done or not done? Not done. See here. N A dot B dot n dimension, B dot n dimension, and B dot shape and B. Now if you run this, now this is 2 comma 2, because 2 rows and 2 columns. I'm saying C equal to A minus B. C equal to A minus B. In the place of minus, I can use one function or not? Yes. What is the name of the function? Sub. You can use a sub function or you can use directly minus. You can use a function called which one? Minus, right? So is it a shape is the same or different? Same. If it is a shape of the array is the same, then will it do any broadcasting or no broadcasting? No broadcasting is done here. Now C dot shape here, right? So is it written with the same or different? Same. That is nothing but 10 minus 1 is 9 and 20 minus 2 is what? 18. 30 minus 3 is what? 27. 40 minus 4 is what? 36. 36. Okay, then I'm writing some D just to see here. NP dot array. D equal to NP dot array. So 1 comma 2, 1 comma 2 comma 3 comma 4. This is 2D array. Some E equal to NP dot array. Now this time I'm creating another 3D matrix. I'm creating it. So 3D array I'm creating it, which contain the number of matrices. The number of matrices. Now I'm writing 10 comma 20 comma 30 comma 40. So this is one matrix. Okay, 30 comma 40. This is one matrix. And then I'm saying 50 comma 60. Yeah. So 50 comma 60 comma 70 comma 80. Now see here. This is which array? 3D array. Now see here. D dot shape comma E dot shape. So what is the shape of this array is? Now you can see 2 comma 2 and this is 2 comma 2 comma what is that? 2. But is it any is the shape of this array is the same or different? Different. Is the shape is the same or different? Different. Shape is a different, right? So this is what? 2D array and this is what? 3D array. This is 2D array and this is 3D array because these are sorry, two different dimensions. Two different dimensions or not? Yes. So what will happen? What will happen if I'm writing F equal to D plus E? D plus E or D minus or E minus what is that? D. I said E minus D, and if I print F, you can see here it is done or not? Yes, because what is the rule? What is the rule? What is the rule again? So number of rules are there. What is the rule? What is the next rule is? See, a rule is you just see. You just see. If the dimensions are the same, see here, where it is here. Now you can see broadcasting only works if the arrays are what? Compatible, meaning their shapes match all the dimensions, or one of the dimensions is what? Equal to. One of the dimensions is what? Equal to. One of the dimension is equal. One of the dimension is equal or not? Yes. So 2 is equal to what? 2. So the number of matrices are same or not? Yes. Then will it do broadcasting or not? Yes. It is converted to what? 3D array. Now you can see 9 comma 18, 26, 36, 49, 58, 67 and 76. So this is on which array? 3D array. This is on which array? 3D array. Suppose assume that, okay, now this is 3D array only. Yeah, just as here. This is 3D array only, but number of matrices I've taken only one. Number of matrices I've taken only 1 here. Okay. Now, if I'm saying print E dot shape, E dot shape, first one is D dot shape. This is D dot shape and one more is what? E dot shape. So what is the shape of this is? 2 by 2. Now that is 2 rows and 2 columns. This is having how many matrices? One matrix and 2 rows and 2 columns. So one dimension matches or doesn't matches? Is it matches or doesn't matches? Any one dimension is matches or doesn't matches? Matches. Matches. Now what I'm doing is I'm writing some G equal to E minus D. E minus D. See here, E minus D, and I'm trying to print. E minus D, I'm trying to print the matrix called which one? G. So here I'm saying print. See here, print G, because one dimension matches or doesn't matches? Matches. Now you can see 9, 18, 27 and what? 36. Understood? Now suppose, assume that. Understood? Or any one dimension matches, then it will do what? Yes. For example, yes. For example, these rules you have to understand here. Shape, take the shape. So 2 comma 2, 1 comma 2 comma, what is that? 2. So 2 is equal to 2. Or is it 2 is equal to 2 or not? Yes. Is it compatible or not compatible? Compatible. Then will it do arithmetic or not? Yes. By converting into which array now? 3D array. Very simple. Okay. But any one of the dimension is 1. Suppose, assume that, okay, h equal to np dot, h equal to np dot array, h equal to np dot array, I'm saying here 5. See here 5. So this is 5 and print h dot shape. Print h dot shape and e dot shape. Now see here, h dot shape and e, sorry. No confusion here. Now 1 comma 1, 1 comma 2 comma 1. Compare it now. Any one dimension is 1. Even it is compatible or not? Or any dimension is 1. Is it compatible or not? Yes. Okay, I equal to h minus e minus, I equal to e minus, what is that? H. So I'm trying to run this code. I try to run this code. See it. I try to print. I try to print which one? I. So these are the rules. Very simple rules only. See here. Very simple rules. It's just to compare it. Yes. So E is a E is a 3D array. E is which array? 3D array with how many matrices? With how many matrices? One matrix with 2 rows and 2 columns. So generally this is called as a cluster contain how many matrices? One matrix with 2 rows and 2 columns. Understood? Or this broadcasting you understood? So only one dimension matches, or any one dimension is 1, it will do what? Broadcasting. See, 3 rules are there. If both the dimensions are same, it will do. If any one dimension is what? 1, then it will do. If any one dimension matches, then it will do. Okay, then it will do it. Any one dimension matches also, it will do the broadcasting. Any one of the dimension is what? 1, then it will do it. Understood? Right? Yes. This is how it will do the broadcasting when you do arithmetic operations. Yeah, next is a minus, right? So all these are arithmetic only. So minus or numpy dot, what is the function is? Sub, not subtract, sub here. I've written subtract. So this function or operator is used to perform element-wise subtraction. So element-wise subtraction is done by using this, right?
Wah.
So like this, you can do all other operations. So you can do all other operations. All operations you can do it, right? I'm writing in one example. I'm not taking number of examples, right? Because this is only arithmetic. So 3 comma 4 np dot np dot array and b equal to np dot array. So 10 comma 20 and 30 comma what 40, right? So c equal to a into b, but this multiplication is done how? Element wise. As multiplication is done how? Element wise. So 1 into 10 is 10 and 2 into 20 is what? 40 and 3 into 30 is a 90 and 4 into 40 is what? 160, like that. So a comma b comma c, a comma b comma c. I'm not telling any broadcasting here. Huh? Yes. So element wise multiplication. Okay. This is element wise multiplication is done here. So this is an example of, element wise multiplication. Element wise multiplication is done using this. Okay. Yes. So this is output here. Multiply. So operator is there. If you want, you can do it by using operator. Multiply. MUL. No. Multiply, you have to use it. So there are two divisions are there. One is a float division and one more is what? Floor division. NP dot array. I'm creating a single dimensional array with 4 elements and b equal to np dot array. So this is also having how many elements? 4 elements. So dimensions are same. I'm saying A, okay, A slash B and D equal to A slash B. So one is a float division and one more is what? Floor division. So floor division is nothing but integer division, right? So you can see 1, now 10, sorry, A by B I said, no? So 1 slash, 1 by 1 by 10 is what? 0 0.1, 0 0.1, 0 0.1, 0 0.1, 0 0.1. But when it is a floor, is it decimal is removed or not? Yes, it will take only integer. I take E equal to B slash A and F equal to B slash what here? A. You are trying to print E and one more is a F. You are trying to print E and one more is a F. And if you run this, you can see this is 10.0, 10.0 and all these are what's here? 10. But it will try to give result in which type? Integer. Floor division is for integer. Example of element wise. Example of element wise. Float division and one more is what? Floor division. Element wise float division and one more is floor division. Float division and floor division, right? So the next is, now you have two more operators. One is modulus and one more is what? Exponent. So A equal to NP dot array with some elements. So 1, 2, 3, 4, 5. You can use A range or random, anything you can use it. NP dot array 10, 20, 30, 40, 50. The number of elements must be same, right? C equal to A. Okay, C equal to B mod A. B mod A. So B mod percentage is nothing but what? Mod, right? So it will create an array with what? Reminders. It will create an array with what? Reminders. I said A comma B comma C. Here I'm using a separator as backslash n. Now you can see 10 mod 1. What is the remainder is 0. 20 mod 2. What is the remainder is 0. 30 mod 3. What is the remainder is 0. 40 mod 4. What is the remainder is 0. 50 mod 5. What is the remainder is 0. So remainder. Now D equal to A to the power of B. A to the power of B or B to the power of A. Okay, B to the power of A. So I try to print D. It's nothing but 10 to the power of 1, 20 to the power of 2, 30 to the power of 3, 40 to the power of 4, 50 to the power of what? 5. So 50 to the power of 5. See here, 10, 400. Yeah, these are number of values, right? So this is an example for mod and exponent. Example of element wise mod and exponent operation. Exponent operation, right? Yes, I think this one you understood. So this is performing some arithmetic operations on array by using which operators? Arithmetic operators. You are doing arithmetic operations by using which operators? Arithmetic operators here. So that is a plus, minus, star, slash, 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 percentage, and one more is what? Star, star. But you can also use the functions. You can also use the functions to perform these operations. Then next we'll see aggregate operations. Performing some aggregate operations. Aggregate operations are aggregate functions. Aggregate operations are aggregate functions. Aggregate operations are aggregate functions. So aggregate functions allows to perform operation on group of data. Operations on group of data. Group of data or what is that? Samples. So group of data or samples. Aggregate function allows to perform operations on group of data or what? Samples, right? So it is provided some aggregate functions like numpy dot. So numpy dot, there is a function called which one?
कौन
Sum. Numpy
काई
dot sum and numpy dot max,
तोते
numpy
सब कौन
dot
सुना होची
min. See, these are descriptive
हैं
statistical operations. So numpy dot sum, numpy dot max,
कौन तो
numpy
फोन
dot
मो पाके
min,
थुआ ହେଇଛି माने कौन
numpy
ମୁଁ
dot
बुझी पाରୁନି तू माने कौन एमती
numpy
पागल
dot
भଳିया
what?
ବେଳେ ବେଳେ କାଇଁ ହଉନି
Mean, numpy dot std, which is nothing but standard deviation, and numpy dot what is the next one is median, right? So mean, median, mode, right? So sum, maximum, minimum, standard deviation, right? So all these are which operations? Aggregate operations. Why you are saying it is aggregate operations? Because aggregate operations always, it perform the operation on one value or more than one value? More than one value. Not on one value. It perform the operation on group of values. So that you can call it as aggregate operations, right? So that you can call it as which operations? Aggregate operations. So this is very important because whenever you want to perform certain, what do you call it as descriptive statistics, then compulsory you go for this functions. In this, the first function what you have is numpy dot, numpy dot. What is the name of the function is sum. But this syntax is very big. I'll just take the syntax from here. So numpy dot sum, because row wise, column wise, complete. You can do row wise sum, you can do column wise sum, you can do what? Complete. Complete array. I mean, you can add all the elements. You can add all elements of the array. You can add the elements row wise, access 0, access 1, access 2, right? Yes, that depends on the dimensions of array. That is depends on the dimensions of which one? Array. So numpy dot, what is the name of the function is sum. Okay, it will do the sum. It will do the sum. It will do the sum by using all the elements, or it will do the sum by taking which one? Access. It is very big. I said, no, this is very big. So it is similar to the way how you do, like when you work with a database tables, right? Will you add the values of a specific column or not? Yes. But when it comes to here, you have a rows and columns. And you can do the sum based on the condition. You can do the sum even based on what? Condition. All these are provided by which one? Sum. Sum. It is helpful when you are doing numerical analysis, right? So numpy dot sum A is nothing but array. And access is default is what? None. Means it will try to add elements of, it will try to add all the elements if you don't define which one? Access. And there is a data type, and there is a outer, and there is a keep dimensions, and initial value, and there is a where. Where is nothing but condition. Where is nothing but what? Condition here. Where you can just give the value. Now let us see all this one by one. What is the first one? A. A is nothing but what? Array. But what it will do? Sum of array elements over given access. What it returns? Sum of array elements over given access. So in this parameters, let us discuss about parameters. So what is the first parameter is A. First parameter is A. A is nothing but array like. A is nothing but what here? Array like. So first parameter is A. So I'm just telling you all the parameters one by one, right? So that you can understand how you can do the sum. So it is nothing but array like. So elements to sum. So let us see an example here. First one, I'm not taking any access, nothing. I'm not taking anything. I'm just giving input as what? Array. It means what it will do? It will add all the elements of what? Array. It will add all the elements of array if you don't give the access. If you don't give the access, now it will add all the elements of array. Now I'm taking an array of single dimension. So 1, 2, 3, 4, 5. Now I'm saying total 1. Total 1 equal to np dot. What is the function is? Sum of A. What is A is? array. Is it add all the elements of array or not? Yes. A comma total 1. A comma total 1. You can see is it add all the elements of array or not? Yes. I want to add the sales of, yes, it is add all the elements of array 1 plus 2 plus 3 plus 4 plus 5. What is the result is here? 15, right? So I create one more array b. So b equal to np dot array. Now I take an array with 2D array 10 comma 20, 10 comma 20, 30 comma what is that? 40 and 50 comma 60. Now this is which array? 2D array. Total 2 np dot sum, and I'm saying here b. Is it add all the elements of the array or not? Yes. B comma total 2. B comma total 2. What is the total is? 210. Is it add all the elements of array? Yes. Okay, then I take one more array. NP dot array. Now this is three-dimensional array with some two matrices, and each matrix contain two rows and what is that? Two columns. Two rows and two columns. 5 comma 6 comma 7 comma 8. This is two rows and two columns. Now you want to add all the elements, total 3 equal to np dot sum, np dot sum c. And if I'm saying print total, sorry, c comma total 3. So I printed array and elements, sum of elements of this array. Getting or not? See here, you have a sales. Assume that you have a sales of, okay, sales of some 6 months. 6 months sales is there. 6 months sales. So 6 months means how many rows? 6 rows. And 6 months sales. 6 months sales means now each month is having number of days. Each month is having number of days, right? So 6 months sales. I want total 6 months sales. Then what will I do? I'll say only what? Sum of this array. If I'm writing sum of this array, will it add the sales of all the 6 months or not? Yes. But I want sum month wise. Sum I want what? Month wise. Means month is nothing but, month is nothing but what? Rows. Month is nothing but what? Rows. Now each month I want day wise. In each month I want what? Day wise. Day is nothing but what? Column. But are you given any row or column? No. You are just given the input as what? Array. What is input is given? Array. It means is it adding all the elements of the array or not? Yes. But you want to do some row wise or what? Column wise. If you want to do some row wise or column wise, you can use what you can use? Access. What you can use here? Access. Access is nothing but where you define. You want to do the sum row wise or column wise. So that can be either one. You can represent it as a tuple. Suppose if the array is empty, can you create an empty array? Na? No. Generally, you create an array with some values. You can also define np dot, sorry, np, suppose I'm writing here some e equal to np dot, what is the name of the function is sum of a, comma, now there is one more argument is there. What is an argument parameter here? Initial. Initial is there. What is the next one you have? Initial value which will be taken at the beginning, right? Which is added at the beginning. Initial is there. It is optional. Starting value or starting value for the sum. Initial starting value for the sum. I've taken this. What is the name of this parameter? Initial is a parameter and it is optional. So what is the name of the parameter? Yes, it is optional and that represents starting value. That represents what here? Starting value. So what is the name of the parameter here? Initial. Suppose if I'm writing initial, suppose if I'm writing initial, here I'm saying initial equal to 100. Means this value is a starting value or not? Yes. It's nothing but 100 plus 1 plus 2 plus 3 plus 4 plus 5. Okay, this 100 is which value? Initial value. 100 plus 1 plus 2 plus 3 plus 4 plus 5. 100 plus 1 plus 2 plus 3 plus 4 plus 5. Now you can see this is some total 4. Total 4. Now this is a total 4. You can see this. What is the value it is taken? 115. Actually 1 plus 2 plus 3 plus 4 plus 5 is what? 15. But what is the initial value I've given? 100. It's nothing but 100 plus 1 plus 2 plus 3 plus 4 plus 5. So that you can call it as which value? Initial value. So you can define the initial value of the array. You can define the initial value of sum. Sorry. You can define the initial value of sum by using one parameter called which one? Initial. By using a parameter called initial. Right? So in the same way, yes. Okay, in the same way, there is one parameter. This is very important here. And what is the name of this is? Access. You want to do the sum. You want to do the sum along with the access. Access 0 or access 1, right? Access 2 if it is having multiple dimensions. So what is the access defined is, now see here, access is there. One more parameter called access. See here, this is very important. And none are integer or tuple of integers or it is optional. If you don't give the access, what will happen? It will add all the elements. If you don't give the access, what will happen? It will add all the elements. All the elements it will get added. All the elements get added, right? So what is the name of the parameter here? Access. So I am writing separately this because this allows to do the addition of elements along with the rows and columns. So access is none. Access none or integer or tuple of integers or it is optional, right? Access or accesses means multiple along which a sum is what? Performed. The default access is none. Will sum all the elements of what? Input array. So the access is negative. It counts from last to what? First access. If access is tuple of integers, a sum is preferred. A sum is preferred on all the access specified in the tuples instead of single access or all access as before, right? Yeah, let me tell you. So how you want to do the sum? How you want to do the sum? Okay, you want to do adding of all the elements or you want to do the sum along with what? Access. Along with what here? Access. Let me tell you. But when you go for this access, if your array is what? 2D array or it is what? 3D array. If it is 1D array, how many access will be there? Only one access. But when you define the accesses, when you work with 2D or what? 3D arrays, right? Suppose I'm creating an array. I'm creating an array with number of rows and columns. NP dot array. NP dot array 1 comma 2 comma 3. Then I'm saying here 4 comma 5 comma 6. I'm writing here 7 comma 8 comma 9. Okay. So 10 comma 11 comma 12. Right. So here I'm taking an array with which array it is? 2D array with how many rows? 4 rows. And how many columns? 3 columns. 4 rows are there and 3 columns are there. So print array. So print array here. 4 rows and 3 columns. Here 4 rows are there. And how many columns are there? 3 columns are there. So NP dot array, 4 rows and 3 columns. 4 rows and 3 columns, right? Okay. Now, anyway, if I'm writing a total 1 equal to NP dot sum, and I'm saying what here? A. So if I say sum A without access, what will it do? Add all the elements. Add all the elements. And what is the sum of all the elements? 78. Okay. Then B equal to NP dot sum A comma. What is the name of the parameter? Access. What is the name of the parameter? Access. And I said here access 0. What I said here? Access 0. Access 0. And I'm saying print B. So print B and it will return array. It will return array. Now what is the elements is 22, 26 and 30. Access 0 is nothing but what? Rows. Access 0 is a rows or columns? 1 plus 4 plus 7 plus 10. Is it 1 plus 4 plus 7 plus 10 or not? Yes or no? So 1 plus 4 plus 7 plus 10. What is the sum is? 22. 2 plus 5 plus 8 plus 11. What is the elements is? 26. 3 plus 6 plus 9 plus 12. What is the sum is? 30. So is it access 0 is a row or column? Row no column? Column. This is a row. Yes. So this is a row. Row, column. This is column, right? Access 0 along with the rows here. This is access 0 and this is access 1. This is access 0 and this is access 1. Access 0 and access 1. Access 0 and access 1. Let me tell you, C equal to NP dot sum. NP dot sum A comma. A comma, what is that? Access. Access is what? 1. So print C. C is another array. C is one more array which contain 1 plus 2 plus 3. What is the sum is? 6. 4 plus 5 plus 6. What is the sum is? 15. 7 plus 8 plus 9. What is the sum is? 24. 10 plus 11 plus 12. What is the sum is? 33. Because it is which array? 2D array. So 2D array you have how many access? 2 access. That is access 0 and access 1. If it is 3D array, you have an access 0, access 1, access 2. Access 0, access 1 and access 2. Access 0, access 1 and access 2. Let us see more dimensions on this. But this is 2D array. Yeah, you understood up to this, right? All of you? Is it clear up to this? So you understood what is access 0 is? Okay. And access 1. But we'll see more on this because it is very big and very important. And we'll discuss all these parameters. Like what is the out, what is the keep dimension. We have seen initial value, right? Even we'll see access. Access is not completed. I'll tell you more about this and even about where. Not today, but we'll see tomorrow this, right? So today we'll stop here and tomorrow we'll continue this, right? Thank you. We'll see tomorrow.